If you have already watched my video on multiplying rational expressions, there really isn't going to be a whole lot of new stuff on this one. There's really only one extra thing that is different when you divide rational expressions. But if you remember, back to whenever you were first taught with dividing fractions, usually there's some sort of cute little way that teachers will give it to you. For me, I was always taught KCF, keep, change, flip. Effectively, if you were ever trying to divide by a fraction, that is the same thing as multiplying by the reciprocal of whatever you're dividing by, meaning the second term. So when I said KCF, keep, change, flip, that stood for keep your first fraction the same, K, change your division sign to multiplication, and flip your second fraction. And then you just go about and do multiplication the way you would normally. You don't have to remember it by keep, change, flip if you don't want to, but at any rate, if you are trying to divide, take whatever that second term is, whatever you're dividing by, flip it, and then you can just do multiplication the same way you did it before. So like in this case, if we want to know what we would get from multiplying this rational expression, or fraction in this case, we want to break each of these down to their prime factors, see if anything cancels, and then do our multiplication. I only had one number that I wrote that could break down, so that'd be 6, meaning we could rewrite this as 2/3, 2 over 3, times, instead of 6, write 2 times 3, over 5. When I do that, I notice that I do have a 3 in my numerator and a 3 in my denominator, and as we know, that means we could cancel these out, because a fraction bar is the same thing as division, and anything divided by itself is 1. That leaves us with 2 times 2 in our numerator, which would be 4, and looks like just a lonely 5 down in the denominator. So 4/5, 4 over 5, would be our answer for this. It really is, like I said, the same thing as multiplication. You just have to make sure you find the reciprocal of that second term before you do anything else. So, for example, just to give one where we actually have some variables in it, if we've got 5x over 3x minus 12, and we want to divide that by x squared minus 2x over x squared minus 6x plus 8. Well, before I start doing any factoring or looking for things to cancel or anything like that, the first step we want to take is we want to rewrite our first fraction. We're not going to change anything to our first rational expression. But then we want to flip our second rational expression, our second fraction, so that we can multiply. Right? That's all you got to do that's special. Everything else is going to be exactly the same as what we would have done with multiplying rational expressions. But to still finish this out, because, never hurt to do an extra example. To me, looks like 5x is already factored. I don't see anything else I could do with that. You can write it as specifically 5 times x instead of 5x if you want to put like a dot between them, but that's about it. Now for our first denominator, the bottom left, it does look like there's a GCF there. I believe 3x and 12 could both divide by 3. So let's pull that 3 out. That would leave us with x minus 4 inside the parentheses, as negative 12 divided by 3 would be negative 4. Taking a look at our second numerator, the top right, x squared minus 6x plus 8, we would need to find two numbers that multiply to a positive 8 but add to a negative 6. Well, negative 4 times negative 2 would be a positive 8, and negative 4 plus negative 2 would be a negative 6, meaning we could factor this to x minus 4 and x minus 2. And then finally, our second denominator, the bottom right, while that does look like something we could try and factor with the x method, in reality, we just have a GCF to do here. I noticed that x squared and negative 2x both have an x in common, so we could pull that out. X squared divided by x is just x. negative 2x divided by x would be a negative 2. Now that we have fully factored all of our parts, let's see what can cancel. I see an x minus 4 in my numerator and an x minus 4 in my denominator, so we can cancel those. I see an x minus 2 in my numerator and an x minus 2 in my denominator, so we can cancel those as well. I also see a standalone x and a standalone x in both numerator and denominator. If you did not notice that, then you probably should start writing 5 times x with a dot in between there to remind yourself. If you saw that coming, then no big deal, you're fine to write it however you need to. Either way, we can cancel those x's out, which means it looks like we are simply left with a 5 in our numerator and a 3 in our denominator. So 5/3 would be our answer here.